here's some examples with implicit differentiation. So remember what we're doing here is we're considering that y is a function of x, and we're going to take the derivative with both sides of the equation, and then solve for dy dx. Keeping in mind, of course, that when I take the derivative of y or any function of y, I have to also use the chain rule and get a dy dx involved. So here on my left-hand side, I've got e to the x times sine y, product rule, right? So I've got e to the x d dx of sine y plus sine y d dx of e to the x. On this side, I've just got the derivative. In fact, I'm just going to write it this way, the derivative of x plus the derivative of y. Right? Now here, derivative of sine is cosine, but again, it's sine y. So chain rule, I'm going to get cosine y dy dx here. Here, I'm just going to get an e to the x back. Here I get a 1, and here I get dy dx, right? So you guys feel free to use the prime notation if you prefer. I like the dy dx in this case because I find it easier to remember that I'm taking the derivative with respect to x, but y is then a function of x. So I'm going to put the dy dx over on this side. So I got e to the x cosine y minus 1 equals 1 minus e to the x sine y. So then solving for dy dx, you get this guy. Okay? So that's my first example. So you can see you've got a product rule in there, etc. My second example over here looks like it's got a quotient rule there. I can do that with the quotient rule, but I can also make my life easier if I just multiply through by the x plus y. To be honest, that's what I'm going to do, because I don't want to do the quotient rule if I don't have to, and this seems like it's a little bit easier if I do this, right? Then I have x y squared plus y cubed plus x plus y. Okay. Now I take the derivative of both sides with respect to x. All of these are fairly straightforward, except this one's got an x times a y squared. So this one also is going to be a product rule, but it's a pretty simple one, right? Derivative, x times the derivative of y squared plus y squared times the derivative of x. And the rest of these are just kind of what I'd expect. I'm just going to write them all since I started. I'm just going to write them all like that. But yeah, you don't have to write every step out like that. So go ahead and going through these, the derivative here is 2x. Here I've got x times 2y dy dx. Whenever I've got the y, I get the dy dx, or whenever I'm taking the derivative of y. Now here, dx is just 1. So this one's y squared. This one becomes 3y squared dy dx. This one is just a 1, and then this one is just dy dx. Okay, so I'm just going to flip the right and left. This is going to be 1 plus 2xy plus 3y squared dy dx. I'm putting the other stuff on the other side. I get 2x minus y squared minus 1. So my final answer is going to be here. Now, if I wanted to take the second derivative, which I'm not going to do right now, but just if I could, if I did want to, I could take the second derivative. I then take the second derivative of the derivative of this whole thing. Again, now I'm going to still do it, of course, implicitly because there's x's and y's, and yeah. Excuse me. So there may be one like that on the homework. They can get pretty messy, so I would start with something that was a little bit easier, probably, if I was going to do one. But essentially, it's no different. You just take the derivative again. Okay, so last one here. Want to notice that we have here x times y and here x plus y. So the difference is there's going to be a little bit of a difference, right? If I take the derivative here, both of these, I'm just going to write it this way, right? Both of these are chain rule ones, right? So the derivative of sine is cosine, so I'll end up with, let me put this here so we can see, cosine of xy. Now I've got times the derivative of xy, and then the derivative of cosine is negative sine, and then the derivative of x plus y, right? So just straightforward chain rule there. Now here, I could write this another time, but I'm going to be a little bit lazy, you guys, because we did x times y just a minute ago. So this is a product rule, right? Because you have to think of x as being an independent variable and y as being a dependent variable. So what I'll get is that times the derivative of that. So dy dx plus that times the derivative of that, y times dx dx. So I'm just going to leave that as plus y there. And then over here, the derivative of x is 1, and then the derivative of y dy dx. Okay? So now I still have to clean this up, but this is so where we have gotten to. You see the difference that you have when you've got the product. You have to use the product rule. When you have the sum, it's a little bit more straightforward. So dy dx, and then I'm going to have an x cosine xy, and then plus sine of x plus y, and then the right-hand side would be minus sine of x plus y, minus y cosine of xy, right? And then I just divide by this guy to get the final answer.